Hello and welcome everyone. In this video, we will use another important method to solve a system of linear equations. This method is known as QR decomposition or factorization method. As I said in the previous video, I have now pushed the code for all the algorithms in this playlist, including the QR decomposition, to my GitHub page. I will add the link in the description. So please subscribe to my channel and like this video. The key step in this algorithm is decomposition, in which the matrix A is written as the product of an orthogonal matrix Q and an upper triangular matrix R. We can use several methods to perform this decomposition, such as Gram-Schmidt orthogonalization and Householder transformation. Then the method to solve system of linear equations can be described in two steps. We have the original system in the form of Ax is equal to b. We perform QR decomposition and substitute A on the left hand side. Since Q is orthogonal, the product of Q with its transpose is an identity matrix. Using this, we can get the expression Rx is equal to Q transpose B. Let's say Q transpose B results into the vector y, and since R is an upper triangular matrix, we can easily solve this system using back substitution. Let's solve an example using Python code. In this case, we have three equations and three unknowns. Let's see how the QR decomposition code looks in Python. We use the QR function from the NumPy linear algebra package. Then we use back substitution to find the solution. In the main file, we write the matrix A and vector B for the given system of equations. Then we get the solution using the QR decomposition function from utils.py that we just discussed. We can then check if A is the product of Q and R and is X the correct solution, that is, it satisfies Ax is equal to B. And we can see the answer is yes to both questions. With this, we conclude this video. Thanks for watching and see you in the next video.